ones there?
They're all there. They're just, yeah, you have to kind of follow them in order. They're there. They're playlisted. I put them in order. I upload them in order of how I record them, and I link the link you go to on the schedule page is the first one of the day, and then I'm assuming you could probably fast forward through that one if you wanted to get to the other ones, but you just okay. I don't know why it didn't work because it's there. We'll do it right now. That's what I'm saying. I'll go over here and show you for sure. Because it is a nice choice. Now realize this is nothing you have to do. You can do this all manually. It's just much, much easier to use your TI to do it because your TI then acts as, oh, thank you. I was going to throw it out just on the screen there. Perfect. But yeah, I mean, for sure. We can look at it again. I mean, and again, part of this is a function of, and sorry about the 89 show. I didn't think about that. I apologize. Part of it is a function of, I don't know who you guys had in 95, and I don't know how much TI work you did. When I used to teach 95 back in the dark ages, that we did this 2/3 of the time. We were always on the machine, always doing graphing, always intersecting lines, and Joe shaking his head. And it depends on who you have, I think, a lot of the times. Now, I haven't taught 95 in like 3 years, so I have no idea what the curriculum is even anymore. But when I was teaching it, man, we were in this thing all the time, constantly graphing, constantly doing exactly this kind of thing. Now, I don't make the assumption that everybody uses it as much as I do in 95, which is why we took that last part of class last time to kind of knock it out. But I think the big question isn't the slope calculation. I think everybody followed that because we were doing that all day long. When the slope calculation moved to the TI, I think that's when people were getting maybe a little bit freaked out. So I think you're overthinking it. And here's the deal. Here's the deal. Here's the data from class. That's my bike data. Got my distances. Got my times and seconds. All is well. All is well. I'm going to change that scale on the y-axis. That bothers me a little bit. I'm going to go 0 to 230. We're going to go by 25. That's better, I think. So you see the curve going up there? That's the best fit curve. That's the best fit parabola. That's what we're going to use. That's what we're going to use today. So I'm going to turn the scatter plot off. Like I told you guys in class yesterday, it seems to me easier if you don't have it on. Because if you have it on with the curve and you press the trace button, it's going to jump onto the plot first. And then you can jump off the plot onto the curve. And so if you forget to do that, then you're going to get pissed because you're going to keep trying to do something that you can't do. So there's just the curve.
Okay, how did you get the line part? I have the plot.
It's what we left over from yesterday. I ran the quadratic regression. So we did the exact same thing as a linear regression, but we ran a quadratic regression instead. So instead of picking 4 like we would do before, remember how we pick 4 lim reg ax plus b? We pick 5, which is quadratic. I'll show it to you on the home screen there. That quadratic right there. And I think, and this goes what we're going to be using today, Di's question is, how did I get it into the screen?
Yeah.
Make sure when you type it like this. Quadratic y1. Page 4, paragraph 1 of your booklet. Page 4, paragraph 1. I'm not exactly sure on your booklet which one it is, Shell. I know it's in there. I know it's in there. I just don't know what page it is. I don't know it off the top of my head as quickly as the TI-83. Yeah, Linda.
And those are the numbers up there?
Those are the numbers, actually. Yeah, I made an Excel spreadsheet to make it a little more graphical, a little more dynamic. We'll play with this in a minute.
Can we put the averages, all the numbers in
Yes.
there? Yeah. Okay.
That's what, every point that you see up, well, you don't see it now, so I turned it off. Hang on a second, Linda. Every point that you see on this graph right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, is one of those 9 points right there.
Well, no, what I was saying is like the 6.1466666.
Yeah, he did have us put in each
Exactly. Okay.
decimal.
Yes, that's what I'm saying. Each one of those points you see there is one of those. So if I hit trace, you can jump along, there they all are.
I know.
Each one.
Thank you.
Sure. Okay, so I'm going to turn that plot back off. Now, I think what's hanging us all up, and again, part of it was the TI use at the very end. Everybody totally bought the total distance over total time. Everyone was on board the entire time. And I said, check this out. Here's a way to use the TI to do a shortcut for it. And then we started using the Y1 with parentheses, and I think everybody was getting freaked out a little bit there. So here's why you shouldn't freak out. So check it out. On this curve, everybody, if you would, press the trace button and just get somewhere on the curve. Get somewhere on the curve. Get your spider. Get your spider. Move it around.
Why my X and Y say 0?
Well, is your plot turned on? Is your scatter plot turned on? Or does it look just like mine, or is there a plot on too?
It's just got the little plots and no line.
Okay, well then that's why you have to do the quadratic with the Y1.
I know, and I don't know.
Okay, good. Do that, and then you'll be able to do what
I
I'm
don't
doing.
know how to do that.
What's that?
I don't know how to get that. Is that Vars?
That is, you got it. You got your booklet, right? Got it. Just walk yourself through that. You got it. You got it. Now, let's all get the same point on the curve. Let's all get the same point on the curve. So everybody type 7.
See, it takes me to quit. It says in.
Everybody type 7 and get the y value and make a note of what it is. Okay. Invalid quit. Oh, you have to put quad reg first.
That's what I've been doing.
It's right. It's 5 instead of 4. Quad reg, y vars, boom. There it is. And there they come. It's gonna take its time. And now you got it. And you can turn your plot off now and just go off the equation. Okay? Everybody getting the same y values as me? We got x equals 7, which means at 7 seconds, I'm about 67.5 feet away from where I started. 67.5 feet away from where I started. But so far. Now, if you were doing a secant line calculation, that is the y value and the x value you would have to use, and then you'd have to pick some other x and y value. And I think we were using the 12 point, I forget what it was, 12.289 I think was the one we were using for the final seconds as I crossed 200 feet. Okay, and that's cool, we'll come back to that, But here's the deal. Quit second mode. Get back to your home screen. Now type this. Vars, y vars. So hit the vars button,
Go back. I hit second.
Arrow
Go
over.
back.
function, y1. Now that button keystroke sequence should sound familiar. It's the same one you use when you put y1 after quad res. It's exactly the same button sequence. We're going to do something different with it. Don't press enter right now or you'll get an error, because the TI right now is confused. Right now it's waiting for you to tell it something. Do you know what it's waiting for you to tell it? Here, I'll start. It's saying, okay, Sean, you want me to give you a y value, but I need to know. That's what it's waiting for. So that's what you put in parentheses. Left parentheses, and you put an x value in. For example, 7. Close parentheses. Press enter. Does that number look familiar?
Yeah.
That's that y value that we had from the graph before. By tracing and going into the graph and pressing enter.
Is that function of x?
It is. It's y as a function of x. I mentioned that yesterday and people started freaking out. I put y equals f of x and I started to dry heaves. I want to leave it at that. But yeah, that's all that is. It's a function of x. It's what is the y value when x is 7. So in class yesterday, or whatever that was, Monday, when we were doing the rates change between 2 points, it might have looked super confusing, but it was just in the numerator 2 y values, and in the denominator 2 x values. So I was just using that command twice all at once, and then the x command twice all at once. I think that's what probably did you in. I think that might have been what did you in, was having it all in one line by itself. But again, my apologies. I'm used to Math 95 doing the quadratic formula all in one line on the TI, or evaluating these crazy radical expressions all in one line on the TI. So I'm just used to Math 95 students and I apologize. I'm just used to that, inundating Math 95 students with symbolic manipulations. So I'm sorry if I freaked you out. I didn't mean to. It wasn't my intent. My intent was to make life easy. It seems like I made life harder. Now, of course, you don't need to do it this way. I mean, in the quiz I said use your TI, and here's why. Suppose you needed to figure out the average rate of change between 7 seconds. Let's swing up to the Excel sheet here because I can show you graphically. Between 7 seconds and the time I crossed that 200-foot mark. Back this out. Swing it up. Okay, now what I did here, this blue curve that you see right here is the exact same curve that you guys have in your TI. It's exactly the same. Same exact equation, same exact relationship. The red line that you see is called a secant line. You don't have to know that. But that's the average rate of change line. That's the average rate of change line. So when you guys calculate the average rate of change, what you're actually calculating is the what of that line. Do you remember?
Right.
The rise over the run. You're calculating the slope of that line. Exactly. That's what we were doing yesterday. So you can see right now, if I start, let me zero it out real quick. If I start at 0 seconds, as 0 seconds, and I end at 12.289. Now it's giving you more decimals, but that's fine. It's just using more precision. The average rate of change is about 16 feet per second. Does that sound familiar from last class?
Yeah.
Hell yeah, it does, because that's what we calculated it as, to the nearest foot per second. We rounded it off to 16 to the nearest foot per second. And then what was our interpretation of that? 16 feet per second, average rate of change. What does that mean?
Every second, 60 feet.
On average. Now, Benji, who's not here, unfortunately, he asked a great question. He's like, is there some point along that curve where you actually were going 16 feet a second? Let's come back to that. Yes, the answer is yes, but let's come back to that. The question is, am I going 16 feet a second right here at the beginning?
No.
Am I going faster or slower?
Slow.
Definitely slower, since I'm starting at a dead stop. So I'm not going any speed at all until I start rolling, and when I'm rolling, I'm not starting to go 16 feet a second. Am I going 16 feet a second at the end over here?
No.
Am I going slower or faster?
Faster.
But so what is the 16 again?
An average.
It's an average. If I have to cover 200 feet in 12.289 seconds, I have to do it 16 feet per second on average. So if I was to travel actually 16 feet per second, I would cover the 200 feet in 12.89 seconds on average. But that doesn't talk about how fast I'm going at the end. Remember the goofy analogy I gave you? We're trying to use the same mathematics the police and those cool radar signs use on Archie Briggs and on 97 to show you how fast you're going. I gave you a silly analogy. If we checked your speed like this, where would the police start checking you? When you were in your driveway, and they would kind of they would then hit you there, and then they hit you, I don't know, 5 hours later when you were in Portland, and say, oh my God, you were and you would take it right to court. You're like, what the hell? You're giving me a ticket for speeding from here when your first point is way back there, which has nothing to do with where I am right here. And that's when we started messing. And that's what the quiz was all about, was to, how can we refine? Because what was the question we started by asking? What was the question I wanted to know? That I made you write down estimates for?
How fast?
How fast was I going right there? So what I wanted you guys to start doing was to move this point closer and closer to that point. Now check out what we just did. I'm going to slide this bad boy to 7. What's happened to the slope of that line, FYI? What's happening to the slope of that line? Is the slope getting smaller? The line itself is getting shorter. I agree with that, but what's happening to the slope of that line? It's increasing. It's getting steeper, isn't it? It's getting steeper. Let's bump this thing out to 7. I'm going to make this white. You don't need to see that. There. These numbers look familiar, friends? These numbers look familiar? 7 seconds, 67.5 feet. They look familiar to you. You can all say yes. Because well, it's off now. But the screen told us that's what it was, right? The screen told us that's what it was. Let's move back over here and turn it back on so you can see it. What's Excel doing? The exact same thing that your guys' TI is doing. Now, Excel's a bit more of a pain in my butt. I had to coax it a little bit more to do that. I had to actually use the original data. I've hidden a lot of stuff from you in here because you didn't see it. I had to actually do the regression and then have it hidden down here, the A and the B and the C, and there's a bunch of points that I had to apply. It's a little bit of a nightmare, kind of like a cell phone. If you ever look inside of a cell phone, it's a nightmare. But when you turn it on, it's like, can I help you? I'm Siri. But the inside of it to make Siri sound all cheerful is actually quite ridiculous. So, there. That should look familiar. 67.5. Now, what is my average rate of change between 7 seconds and 12.289 seconds? Feel free to look up at the board and get the answer, because I've got it up there on Excel. Can you see it up there on the top? I'm not sure it's big enough to see. Can you see it up here?
The 25?
That's it right there. That's the average rate of change from 7 seconds to 12.289 seconds. It's about 25 feet per second. Now, how did I get that? Am I magic? No, God, no. Take a look at the formula inside of there. Ignore the round part. The round part is rounding the answer off. Look instead at this. This minus this divided by that minus that. Wait a minute. That sounds kind of familiar.
Y2 minus Y1.
Y2 minus Y1 over
X2 minus X1.
Follow the cells. Follow the cells. You guys got it. D9 minus D10. D9 is the Y2 value. D10 is the Y1 value. C9 is the X2 value. C10 is the X1 value. So X2 minus Y1 over X2 minus X1. Now, I did not have you guys using Excel to do this. I'm learning, maybe I should. Maybe I should give this spreadsheet to you and let you go home and play with it. Maybe I've learned something for you guys today, thank you for that. But let's go over the TI and show you how you can get this same exact value here. Because you can. Once you've got the equation in Y1, everybody's got it in Y1, right? Everybody's got the curve showing right there?
No, I can't get the Y1.
Not at all.
Bars right, enter, enter.
I did that.
We're not, okay, so like.
Once you have it stored, we can enter the slope formula. So everybody do it with me. Left parentheses. Notice even in Excel I had to use left parentheses, didn't I?
Where are you doing that, on Y2 or something?
I'm just doing the home screen. Just the home screen.
And then the
Do it in the quadratic.
See, even in Excel I have to have parentheses up
He
there.
wants us to turn on.
Order of operations.
So you go Y,
Now, I gotta do Y2.
turn,
Remember, you have to speak TIEs. We talked about this in class last time. Y2 is the Y value at X2. And X2 is the 12.289 seconds. So here's what you do.
Where are you at now?
Home screen.
so close.
Vars, right, enter, enter. Shelly at the break, we're gonna figure out what the hell this is on yours. We are. We're gonna figure it out. I don't know off the top of my head. I got a feeling it's in the Vars menu, which is down on the right-hand side. There's Vars catalog or something like that. We'll find it, I promise you. Then we're gonna tell it what X value to use. So left parentheses again, 12.289, right parentheses. That's Y2. The TI calls it Y1 because the equation it's using is stored in Y1. Confusing? Yes, I don't know why they do that, but they do that. So get used to it. Now we've got to do minus Y1. Y2 minus Y1, just like I said. Minus, which is tight.
Wouldn't that be X2?
Not the slope. Slope's change in Y over change in X. Change in Y over change in X. So this is the Y value when X is this. We now have to do the Y value. The Y value when X is, we're doing 7, right?
Yeah.
7.
You gotta do a double parentheses.
We do, don't we, Nick? We've got to close double parentheses off the first parens that I just had. The first parens that I just had closes off the Y1. The second parens closes off the original parentheses way up there. Take a look before we go any further and count the left and right parentheses and make sure that there are the same number of lefts and rights. And again, my apologies. This is the kind of stuff I hammered my 95 students with. I used to give them ridiculous expressions to put into their calculators so that they would, when they saw something that's like, whatever, dude.
Wouldn't it be 3 parentheses too?
There are 3 right and there are 3 left. Right? That's the whole point, is that we have to make them match. Now, where Excel shines in this, when you look at Excel, it actually color codes them as you're entering them. If anybody's used Excel before. So I'll show you real quick. If I'm up here typing this formula, see all the color coding up there? So if I then hit that, and then I type that, see how it even bolds them? It shows you what it's pairing off with. Why hasn't TI done this? Because we keep buying their crap even though they don't. That's part of consumerism. We keep buying their crap, they have no competition, therefore why spend the effort improving their product? Sorry, soapbox off. There's our numerator. There's our numerator, yes? Now some of you are looking at Excel going, my God, why do you have to do so much on the TI when you do so little on Excel? Trust me, it's not so little on Excel.
No.
That formula right there is very, very simple. But the cell that D9 is referencing, if you actually look down into these cells,
Each one.
look at that. See, there's definitely some complexity going on in here. It looks just like your cell phone. Just like your cell phone. You push the button, it comes on. That belies what's actually going on inside the thing to make it come on. So it does look much, much simpler, that formula up there in cell C4. But trust me, it's nowhere near as simple as it is just this minus this over this minus this. So it's actually easier here on your TI if you had to set it up from scratch. Okay, there's our change in Y. Let's do our change in X. Let's do our change in X. Divide it by. Now,
Parentheses.
gotta open parentheses up. Gotta open parentheses up. 12.289 x2 minus 7, which was x1. Go ahead, Dot.
Okay, so
Linda.
you only have two parentheses after the 7 instead of 3.
I said there are 3 right parentheses in total, not 3 in a row. The number of lefts and the number of rights have to match.
Right, so I see one in front of the Y, I see one in front of the
1,
1.
2, 3.
Right.
1, 2, 3.
Oh, duh. Okay, sorry.
Now, if you take some of those out, things go horribly wrong. I start going 800 miles an hour and things like that. Because of over operations, where I start going negative 20 miles an hour or something like that, which is fun to think about. Ready? Boom! Does that number look familiar? Does that number look familiar? Is it a number that you stated a few moments ago?
What did you push to get that?
I pushed enter.
I did too, and it takes me quit. And I followed your instructions exactly.
You still don't have the equation in Y1. You had to run the quad reg Y1 to get the equation in there. That's why, remember the error you got before? When you were pressing Y1, hitting enter, and it was keep getting quit, quit, quit? That's because it gets confused. It needs something to work off of. So you have to, I'll get you caught up here. You got to do that, that. Now,
We did that.
as soon as it does that, it works just fine. See, what you were telling, basically, Di, what you were telling it was, you were telling it to do the command that's here with these having zeros in it. And it would be like, I would love to do that. It's kind of like giving you the keys and then hiding the car. Go start the car. Start the error. So that's the thing. You have to have the equation in Y1 to actually make it work. I ask again, does the 25 make sense? You see the 25, you know where it comes from? Yes, it's right there. It's the same calculation. Round it off to the nearest whole number. Now, the point of the quiz. Yes, that took some doing to get in there, correct? But the point of the quiz was then I started asking you to change where the first point was. For example, move the first point so that x was equal to 10. I think I used 10, right? At some point in the quiz, I think. You now have a new x1, y1. Do you have to type all that crap again? Gosh, no. You simply press second enter. Second enter, and you go in there and change the 7s to 10s. That's all you gotta do, that's the whole point. That's what I was doing this in class at the very end. So we just go in and change that 7 to a 10. I gotta insert a space, which I showed you how to do, not a big deal. That's all I'm doing. I'm now checking the slope of that red line. Now look at that red line in Excel. It's almost tracing the curve perfectly, isn't it? It almost looks like the curve is the line. That's only because we're pulled back so far. I'll zoom in and show you that there's actually quite a bit of gap. But the gap is shrinking. Press enter. I get 28.76, which is going to round to 29. I put 10 in. Yes, Ariel. That's okay. Now in your quiz, I forget what numbers I actually had you use in the quiz. I've forgotten now what exactly I had you use. I'm just making up numbers now. 10. Now answer that question. Okay, that's a question. That's probably a pretty good yawn I just ruined. Now you can change 10 to 11. And you can change 11 to 11 and a half. And you can change 11 and a half to 11 and 3/4 or whatever else I asked you to do. I think I had you get really, really, really close. Like within a tenth of a second, within a hundredth of a second, and so forth and so on. So all you gotta do is just keep going in and changing that second. You're gonna leave 12.289 because that's when we agreed that I stopped. So essentially what you were doing was you were creating this point and letting it get closer and closer to that point. That's all you were doing. That point getting closer and closer to that point. And what did you notice? What did you notice? Let's slide back out to here. The closer and closer that you got to that point. Watch that average rate of change right there. What did you guys notice? The closer and closer I got. Oh, I went past it. There's 12.2. That's actually technically past it. There's 12.2. What kind of values were you guys getting for the average rate of change as you got closer and closer? I noticed a bunch of you circled, they weren't changing very much. That's correct. That last question, are they changing a lot or are they changing very, very little? They're changing very little. Were you guys getting 31-ish?
Okay.
Ballpark?
Hang on. On the quiz, you had us go backwards. Before that.
Yeah.
Before that. So you didn't have us get closer. You had us
No,
get.
careful. Potato, potato. I said backwards from 12.28, a tenth of a second would be a smaller x value. This is backwards 0.088 seconds from this one. In other words, I wasn't, in here the discussion, I'm using the language, I'm moving this point closer to this one. What you're saying is, what I said on the quiz is different. It's not, it's the same thing said a different way. I'm saying pick the first point back from this x value by a tenth of a second before, a 20th of a second before, a 100th of a second before 12.289. We're saying the same thing mathematically, but just we're saying it in English differently. At what point did I cross 200 feet? At what time did I cross 200 feet?
12.289.
What's a tenth of a second before that? 12.189.
Okay, that's what I did. I just want to make
Yeah,
sure
that's,
that.
but that's no different than what I'm saying right here.
Okay.
I'm saying instead of starting here and working backwards, I'm doing the same thing here, but I'm working this way.
Okay.
And now, if you look at the quiz, you actually had to do essentially this, then this, then this, because the fractions kept getting smaller. 2 seconds before, a tenth of a second before, a hundredth of a second before. Now, I forget exactly what fractions I had you use. But the idea was they were getting smaller, which means you're getting closer to the 12.289 seconds. Which is the same thing as I'm doing right now. I'm starting here and I'm pushing. I think there's a communication problem happening. It's not the mathematics, it's the communication of the English. As opposed to, you're thinking of it as starting at 12.289 and working this way. That's no different than starting here and pushing the point
because we
closer.
still have the two.
12.289.
Yes. But the second number we kept making smaller.
That's the first number. The second number is always 12.289,200. That's y2, x2.
Yes.
The first number is getting bigger. Think about it. The first numbers are getting bigger. If I'm think about this.
Are you getting this?
No. This is not math. This is English. This is not math. What is 1/10 of a second before 12.2 seconds? 12.1 seconds. What is 100th of a second before 12.2 seconds? 12.19. That got bigger. What is 1,000th of a second before 12.2 seconds? 12.199. That got bigger. So as the fraction I'm taking away from 12.2 is getting smaller, the number is getting bigger. This is not a math thing. This is not math. This is we have to make sure it's potato. Or understand.
Okay, I get what you're saying.
Good.
But
So there's no difference in what I'm saying and what you're saying.
we'll
I'm
talk.
just saying it a different way, perhaps.
Yeah.
But the numbers, the first number is getting bigger, just like my first number here is getting bigger. I started at 6, then 7, then 10, then 11. The distance between that point and my 12.289 is getting smaller.
Okay.
But the number itself is getting bigger. Go ahead.
So you wanted us to, on these, use the 12.289 every time minus what you said?
That's why in that top part I said, what number did we agree? At what time did we agree I crossed 200 feet?
Oh.
And that's why the average rate of change was always measured to when I crossed 200 feet. To when I crossed 200 feet.
Okay, well, I just kept subtracting.
Say that again? That's okay, you can grab them back. I did not mean for this much confusion to happen. I didn't mean it to be, it sounds like there was not so much a math problem as what I was asking you to do kind of problem. But that was the whole point, was we have to get this first point closer to the second point. You can't do that if you're moving the second point. The second point has to stay exactly where it is. So that's why you kept using 12.289. That's why, well, it's off now. But that's why I didn't change it on the TI at all.
Well, no. I mean, okay, we'll talk later. I don't want to.
I think we've talked it to the ground. I think that's the point. If it's in the ground, it's dead. But that's the point, is that if I'm asking you how fast I'm going at 200 feet, the moment I cross 200 feet, you have to leave that 200-foot point there.
Yeah, no, I'm not asking about that. It's something different.
Okay.
I'll
Not a
elaborate
problem.
later when we talk.
So the question is, how fast was I going? Yeah, 31 feet per second. 31 feet per second is fine. But give that to me in something I can understand. Did anybody calculate it in miles per hour? Let's figure it out. Now you can do it converted-wise like you did on your projects. But we taught you guys how to use Google for this. 31 feet per second and miles per hour. About 21 miles an hour.
That would, like, I did not expect Google to be that savvy for this project.
Well, that's why I put it in the project, because I want you guys to know that you can do that kind of stuff. And that's, you guys did catch that, right? When I said check all your previous answers using Google. I even spelled it wrong, and it still got me correct. So that's why I had you in that part of the project check your answers, because that way you know you can use Google. Because we're all carrying smartphones around. And back in the day, we had to put apps on our phones to do the conversions. And there were websites, like conversion websites, where you could go to the website itself, type in your unit that you needed. You know, you type in convert, and you can find these websites that you convert to. Online conversion. I used to use this one all the time. So you'd go to the site, you figure out whatever you needed to convert, speed, for example, common speed conversions, from, and you see this is a pain in the butt though. I've had to click 5 times now, where I can just type what I need in Google, hit enter, and it pops it out for me. This website predates Google's ability to do that though. It's still there, because I think people still use it. But Google just gets you there right away. So who said I was going 21? Or 20 miles an hour? A couple of you said I was going about 20 miles an hour. A bunch of you said I was going 30, which is not hard to believe. It's hard to know. If you're standing there watching me go by, it's hard to know how fast I'm going. A couple of you said 15. That's not that far off of 21, honestly. Yeah. About 21 miles an hour. There you go. There you go. What you'll do on your next take-home exam is figure out how fast Usain Bolt was going when he crossed the finish line. The race he set the 100-meter dash record, world record in, which still stands, I believe. I think his time still stands for that. So I got the data from that, from a videotape that I watched. And you guys can figure how fast he was going when he crossed the finish line, and it's kind of freaking terrifying. So, actually it's not. All those guys do is run fast. So, they train to do that. I was reading Lance's book today, or not Lance's, but the book about Lance, Wheelmen, talking about some of the training regimens that he does. This is when he was doping, so it kind of puts a little bit of a negative slant on it. It's like, yeah, I used to ride 61 miles a day. I'm like, yeah, it should be full of coke too. I could probably do that as well. But anyway,
I
you're
love
saying,
reading about what those guys do.
what's that?
I love reading about what those guys do.
Apparently, according to this author, he drank a lot of beer and ate a lot of chili dogs.
I heard
Living the
Usain
dream.
Bolt eats a
Yeah,
lot of
living the
yams.
dream, right? What's that?
I heard Usain Bolt eats a lot of yams and makes them real fast.
I think the fact that he's 18 feet tall and he's got legs that are this big around make him run fast. It's a little bit genetic advantage. So, but anyway, there we go. So apologies for the TI giving you grief. I didn't mean that. If you want to grab your quiz, take it back. Totally take it back. Don't submit something that's going to knock your grade down for sure. Grab it, take it back. The idea was that as that first point slid closer to the second one, all was well. Okay? All right, let's take 5. Let's take 5, clear the air out. The room is really warm today, I've noticed, which doesn't help with math.